project named Shop Smartly using reinforced learning. This project is done by Srikant Tota and Seshai Virla. So what we are going to do is the overview of the Shop Smartly using reinforced learning. Okay, several stores are available to us with varying price and availability. When it comes to time to buy our monthly groceries, transporting yourself to the store comes with a price. To determine the optimal approach for acquiring all the desired items, we should deploy reinforced learning to model these variables. Okay, the main objectives of this project is offering a list of things to be purchased along with the list of stores, each with the varying prices and item availability schedules will help make grocery shop easier to find the best order of stores to visit in order to purchase every item on a given list in the shortest amount of time. So the main approach to this reinforced learning is we in this project we are mainly using technologies like Python using libraries NumPy, SciPy, Matplotlib, and Jupyter Notebook, and we are also using different distributions in reinforced learning like Bernoulli distribution, Gaussian distribution, and Poisson distribution. And we are also using deliverables like creating new environment from scratch, implementing value iteration, and implementing Q learning. We also implementing policy iteration method, also approximation method, and we evaluate methodology based on number of the shops and number of the states, quantity of the shops and quantity of the items. We can get an approximate value function by using a presentation value iteration. So we process vectors using 20 bases to get the parameter vector. We apply the least square projected equation methods. We are also using least square projected equation method to obtain the parameter vector V. So now I am handing this project presentation to Mr. Seshai Virla for code explanation. Hi, Seshai.
Yeah, go ahead to the code.
Yeah, please go
as
ahead.
as he mentioned earlier, we apply a Q learning algorithm to a smart shopping scenario where the agent learns to make optimal decisions on which the shop is visited based on the item availability, prices, and distance between the shops. Q learning is a model-free reinforcement learning algorithm used to find an optimal action selection policy for a given finite Markov decision process. It aims to teach an agent how to make decisions in an environment in order to maximize a cumulative reward over time. Q-learning is a particularly suitable for problems where the environment is unknown to the agent and it must learn through a trial and error. In our project, we use the same algorithm, means the Q-learning algorithms, to find the best shop where we can get the required items which we need to purchase by traveling a very less distance. Okay, to achieve this, we have used the Python programming by considering 4 shops and the 2 items which we need to buy. For that, we have collected the data, means we have collected the random data by comparing the prices with the real world market and included in this project. Oh, can you go to the we are showing the we have included different modules, means Python modules here, and with the data which we have collected from the market. This is the real world data which we collected from market, and if you go down, we have considered the 4 shops and we have selected the 2 items so that by using the Bernoulli and the NumPy, we are finding the distance between the shops. Okay, can you please go down? There is a function like price penalty. By using the price penalty function, we are calculating the penalty based on the price of the items in the next state. Means if the agent goes to the next state, means if the item is not available in this shop, in the current shop, then the agent goes to the next shop, and then we are adding the price penalty, means the penalty to the original price. And if you go to the distance penalty, means if the agent is going to the other shop, then there will be additional distance. Then we need to consider that distance as well. So to find the distance, we are using the distance penalty and we are calculating the distance between them. And we are also finding the availability of the item in the shop. For that, we are by using the availability in the shop function, we are calculating the probability of the finding items in the shop based on the current and the next state. And we have defined the M function, which calculates the value based on the distance matrix between the 2 shops. And now we are creating the state space. Create the state space by considering all possible combinations of buying status from the given number of items. Okay, the state space in the sense, state space is one of the reinforcement learning or the decision-making problems. A state refers to a specific situation or configuration that the system or the agent can be in. The state space is a set of all possible states that the system can occupy. It represents the entire range of situations that the system might encounter. Okay, we have defined dictionaries like P and R to store the transition variables and rewards for the different state actions. Okay, can you please go down to the function take action?
Yes, I'm going.
Yeah. the function take action selects the next state and is associated reward based on the current state and action. And we have used the eGreedy function for epsilon greedy action selecting during the Q-learning process. And by using the Q-learning algorithm, which is iteratively updates the Q value for state action and pairs and returns the learn Q values epsilon rewards. Applies a Q-learning algorithm, display the best policy for each state, plots the rewards during the training, and evaluates the learn policy against the random policies in the series of tests. Can you please go down to the result?
Yeah, sure.
Yeah. If you go to the results, then go to the result, please.
Edit results, right? Okay.
Yeah.
This is the one, right?
Yeah. Can you scroll up?
Okay.
Yeah, here we have the state space, means here we have the 16 states, and after state there will be 1, 1, 0. The 1 indicates this means the shop number, and the 1 indicates that the price is the item is available, and 0 indicates the item is not available. So in the first scenario, in the state 1, we are going to shop 1, and there will be first item is available and the second item is not available. So we are not considering it as we are considering it as best action, but we are not ended with the shopping. So if you go to the next state, then in the next shop, next state, go to the results, show me the results. I'm talking about the state 2. Okay,
This one,
okay.
right?
Yeah, here itself. Go up. Okay, in state 2, open the results itself.
Okay, direct results, right?
Yeah. Okay.
Yeah.
In this we have tested 100 times, and we means by using the main objective of the Q-learning is to test multiple times, and we need to teach the agent to produce the results. So we have tested 100 times, and we have experienced a lot of conditions, and we said to the agent, and the agents will give us the best results. Means the best agents will find the best shop which we need to find, which we need to buy with the less distance and with the less price and with the less reward. Oh, this is how the process ends. Yeah, that's it.